this is Kalpana here. In this video, we are going to see a problem from combined solids or combination of solids from mensuration. So let's get started. Problem. A capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends if the length of the entire capsule is 14 mm and the diameter of the capsule is 5 mm. Find its surface area. Solution. We are given a capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. If the length of each capsule is 14 mm, if the length of entire capsule, not each capsule, sorry. Length of the entire capsule is 14 mm and the diameter of the capsule is 5 mm. The diameter of the capsule is 5 mm. Then we are asked to find its surface area. So surface area of or curved surface area of cylinder plus curved surface area of hemisphere at one end and curved surface area of hemisphere of the other end. Okay. So let's draw the figure vertically. Length becomes height 14 mm and diameter D equals to 5 mm. Given a capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends, and we are given the length of the entire capsule is 14 mm. That is, we are given height of the capsule, which is 14 mm. Okay. And also we are given the diameter of the capsule is 5 mm. Also given diameter of the capsule is 5 mm. That is D equals to 5 mm. Then we know that diameter is 2 times the radius, right? So you write it as 2r equals to 5 mm. Then r equals to 5 by 2 mm. So we are asked to find its surface area. Okay. We know that the curved surface area of cylinder is 2 pi RH square units, and curved surface area of a sphere is 2 pi r square units. So the total surface area of the capsule will be 2 pi r square units plus 2 pi RH square units plus 2 pi r square units. Okay. We have r, right? We are given radius r equals to, we got radius not given, r equals to 5 by 2 mm. Surface area is equals to curved surface area of hemisphere plus curved surface area of cylinder plus curved surface area of hemisphere on the other end. So this equals to, we know that curved surface area of a hemisphere is given by 2 pi r square units. We know that curved surface area of a hemisphere is given by 2 pi r square units, and curved surface area of a cylinder is given by 2 pi RH square units, right? So this becomes surface area equals to curved surface area of hemisphere is 2 pi r square units plus curved surface area of cylinder is 2 pi r h square units plus curved surface area of hemisphere is 2 pi r square units. So you are having 2 pi r square 2 times, that is it is repeating twice, right? So you can write it as 2 times 2 pi r square, 2 times 2 pi r square units plus 2 pi r h square units. Fine. So now we need to find the values of radius of hemisphere, radius and height of cylinder. Okay, these two from cylinder and radius of hemisphere. So we are going to find the values of RH. See, we have the total height of the capsule is 14 mm, right? And we have radius. We have radius r equals to 5 by 2. Radius same radius we have radius of the capsule, that is r equals to 5 by 2 mm. Then radius of hemisphere and cylinder will be 5 by 2 mm, right? If we have the radius of hemisphere then obviously we'll get the height of the hemisphere. Since radius and height of the hemisphere are same, or equal, we can say. Then that is we'll get height of the hemisphere is equals to 5 by 2 mm. Okay. Now consider hemispherical portion. From hemispherical portion, we have h equals to 5 by 2 mm. And from cylindrical portion, we have r equals to 5 by 2 mm. Okay. And height of hemispherical portion is also 5 by 2 mm. Now what we need to find? Height of the cylinder. Height of the cylinder equals to total height minus height of hemisphere minus height of the hemisphere. Height of the cylinder is equals to height of the capsule minus height of these two portions. Okay, height of hemisphere minus height of hemisphere. You could write it as height of the capsule minus 2 times the height of hemisphere, which is equals to height of the capsule is 14 mm minus 2 times height of the hemisphere is 5 by 2 mm. So here 2 gets cancelled, is equals to 14 mm minus 5 mm. 14 minus 5 is 9 mm. So the height of the cylinder is 9 mm. Okay, so we have hemispherical portion, cylindrical portion. Now coming to cylindrical portion, we have height equals to, radius equals to 5 by 2 mm and height equals to 9 mm. Now substitute the values of r and h to find surface area. So this equals to 2 times 2 into take pi 22 by 7 into r square, r of hemisphere, 5 by 2 mm whole square, plus 2 into take pi 22 by 7 into r. R of a cylindrical portion is 5 by 2 mm into h. H is 9 mm. Okay. See here we have radius common for hemispherical and cylindrical portion. So this equals to 2 into 22 by 7 into 5 by 2 mm whole square can be written as 5 by 2 mm into 5 by 2 mm plus 2 into 22 by 7 into 5 by 2 mm into 9 mm. So this is equals to cancel 2's here also. Then this is equals to 22 into 5 5 is 25 into millimeter square by 7 plus 22 into 5 nines are 45 into millimeter square by 7. So this equals to 25 into 22 is 2 5 is 10, 2 2s are 4 5, 550, 550 mm square by 7 plus 45 into 22. 2 5 is 10, 2 4s are 8, 8 plus 1 9, 990 mm square by 7. Is equals to 550 by 7 plus 990 by 7 into mm square. Simply we are taking mm square common, okay? So this is equals to 550 plus 990 by 7 into mm square. 550 plus 990 will be 0. 5 plus 9, 14. 5 plus 9, 14. 14 plus 1, 15. Is equals to 1540 by 7 mm square. Okay. 7 ones are 7 twos are 14, 1 4, 7 twos are 14, 0. If you want, you can check 220 into 7, 7 twos 14, 7 twos 14, 14 plus 1, 15, right? So this is the answer. Therefore, surface area of the given capsule is 220 mm square. This completes the problem. Fine, so we have seen a problem from combination of solids in this video. Hope you will understand. We'll see you in the next video. Until then, bye bye.